video tutorial, I'm going to be going over performing the transformations on a function. If you're still not up to speed on what the transformations are, I suggest you watch the other video on basics of transformations. So, in this problem, I give a function f of x, and the first thing we're going to do is we're going to slide the function to the right 2. So you should be able to immediately identify that we're dealing with h if I'm going to be sliding to the right 2. So I don't need to worry about a or k, so I'm going to have f of x, and if I want to slide to the right 2, I'm going to have f of x minus 2. So this is the transformation I want to do on f of x. If you notice, I used to have x here, and now my x is going to become x minus 2. So what I'm going to do is I'm going to start writing this function, but as soon as I see x, I'm going to plug in or substitute x minus 2. So I'm going to have f of x equals, instead of writing that x, I'm going to plug in x minus 2. Now I'm going to keep on writing the rest of the original function. So I had a minus 3, and that is all squared. Next thing I want to do is I want to try and simplify this. So combining any like terms, multiplying anything I can, so I can clean it up. So what I can do is I can do this minus 2 and minus 3. So I'm going to get f of x equals x minus 5 squared. That is my new function. The next step in the problem wants us to then slide the function down 3. So that's not a, that's not h. We're going to be dealing with k. So I need to do f of x, and then if I want to do down 3, a slide down 3, I'm going to do minus 3 for k. So what I'm going to do is I'm going to take my new function f of x, I'm going to substitute it in right here for f of x. So I'm going to take this piece and substitute it in right there. So I'm going to have parentheses x minus 5 squared, and then I've done my substitution, and I still need this minus 3 on the end for my k. The next thing I want to check for is there any simplifying I can do there? And there is not, because that square on the parentheses restricts anything else. So that is my final f of x function. Another example, I have a new function, f of x equals the absolute value of x. So the first transformation we're going to do is reflect the function over the x-axis. So I know if I want to do a reflection, that has to do with a positive or a negative sign on a. So if I want to reflect it over the x-axis, what I'm going to do is I want a negative in front of f of x. So I don't need to worry about ah or k, I just want a negative out front of my f of x function. So what I'm going to do is I'm going to take f of x, which happens to be the absolute value of x, and I'm going to substitute in for here. So I already have the minus sign, and as I substitute this in, I'm going to have a negative absolute value of x. This is my new function f of x. So f of x is now negative absolute value of x. The next step is I want to vertically stretch this by 2. So thinking back to the basic transformations of ah and k, I know if I want to do a vertical stretch by 2, I'm going to do 2 times f of x. So I'm putting a 2 in place of a. So what I'm going to do is I'm going to take my new f of x function, and I'm going to plug it in for f of x. So I have 2, and then since I'm substituting, I'm going to plug it in negative absolute value of x. Last thing I want to do is try and simplify this. I can actually do 2 times this function. I'm going to end up with negative 2 absolute value of x. That is my new function f of x. This reflects a transformation of a reflection over the x-axis, as well as a vertical stretch by 2. That concludes performing transformations on functions.